Hi folks, in this video we're gonna go through Subnet Mask. In Google it says a subnet mask is used to divide an IP address into two parts. One part identifies the host, the other part identifies the network to which it belongs. I've made a note here that I scan. First, introduce Octet. Octet contains 8 bits, with each bit can be turned on and off. 1 for on, 0 for off, you can say. And this octet has the decimal value of 0 to 255. How to calculate the decimal value from an octet? These numbers below signifies what each position in the octet represents in decimal. The first position is 1 if it's on. Second position if on is 2. Third one 4. Fourth one 8, 16, 32, 64, 1 to 8. So here are some examples. To represent 128, you just have to turn on the 8th position, right? So it's 1 0 0 0 0 0 0 0. In the other extreme, if we turn on every position, so that's 1 1 1 1 1 1 1 1, then it will be 255, right? So to get 254, you just have to subtract 1. So you just have to turn on everything except the 1. So that's what it is here. The other one, you need to put a bit of effort. 222 is equal to 128 plus 64 plus 16 plus 8 plus 4 plus 2. So you just turn on the digit corresponding to these. So you get 110111110. Similarly, you get 125, which is 64 plus 32 plus 16 plus 8 plus 4 plus 1. So you turn on those digits. So it's 0 1 1 1 1 1 0 1. 122 is 64 plus 32 plus 16 plus 8 plus 2. So if you turn those on, it becomes 0 1 1 1 1 0 1 0. Lastly, 224 you can get by 128 plus 64 plus 32. So you turn the last 3 digits. So it's 1 1 1, and then all others are 0. Okay. IP address consists of 4 octets. Let's try to write this IP address into octets. 192.168.0.3. So we got 192 here, which is 128 plus 64. 168 is 128 plus 32 plus 8. 3, you just turn on the first 2 digits because 2 plus 1. So if you align them, on 192 is this one, 168, and others are 0. The last one is 3. So that's how you represent IP address in terms of octets. Okay. Now for the subnet mask. Subnet mask is divided into networks and host portions. This is called a class C subnet mask. We'll see why in a minute. 255.255.255.0. If you represent that in binary, it becomes this. So the network portion is start from the last digit all the way until the next digit becomes 0. Okay, and the host mask are you go from the first digit to the left. You stop when the next digit is 1. Okay, in this case the network portion is this, host portion is this, and I set here n here. The variable n is just the number of bits that are turned on. Okay, so you can guess it's 3 of the octets, so it's 8 times 3, so it's 24. This is how you represent a network masking, subnet mask. You write its IP address and then slash and then number n, which is number of bits that are turned on. There are 24 bits that are turned on, or 1, so you put slash 24. Okay. So there are 3 classes of subnet mask. 255.0.0.0 is class A. 255.255.00 is class B. 255.255.255.0 is class C. So now you know why this is class C, because it corresponds to this line over here. Okay, the max number of networks is formulated by 2 to the power of n, where n is just the bits that are turned on, number of bits that are turned on, in this case 24, and the maximum number of hosts is just 2 to the power of number of bits that are turned off, in this case 8. So it's 32 minus 24 is 8. Okay, and then you subtract 2 from it. Okay, consider class A subnet mask 255.0.0.0/8. Here number 8 corresponds to number of bits that are turned on, which are these. There are 8 of them, so you put 8 here. Okay, so as usual, these are the network portion and these are the host portion. So the variable n is 8, because there are 8 bits that are turned on. So there are 2 to the power of 8 possible networks. And if you subtract 32 from 8, you get 24. So there are 2 to the power of 24 minus 2 possible hosts. Okay. Now consider class B subnet mask 255.255.0.0/16. You can tell why it's 16, right? It's just number of bits that are turned on, and these 2 are turned on, and there are 8 bits on each, so that's 16, right? So there are 2 to the power of 16 possible networks and 2 to the power of 16 minus 2 possible threads. Now have a pay some attention to this one. 255.255.222.0 is not a valid mask. You can see that if you convert it into a binary. You can see that this is okay. Every bit are turned on. This is okay too. But this one is not okay, because for it to be a valid mask, every consequent digits need to be 1, except at the boundary. But this 222 is 110111110. So because of this 0 here, it's not a valid mask. But if you do 11111110, then that is a valid mask. Hope you understood that. Okay, consider 255.255.224.0/19. Pay attention here. This is a class B subnet mask because there are 2 what do you call this, Well, in this case, first octet and the second octet are 255, but the third one is less than 255. So this is a class B subnet. Okay, so this is the networks portion, this is the host portion. There are 19 digits that are turned on, so there are 2 to the power of 19 possible networks, and there are 13 bits that are turned off. So it's 2 to the power of 13 minus 2 possible hosts. Okay. Consider 255.255.255.0/24. This is a class C subnet mask because there are 3 255s beginning from left, right? So there are 3 octets, so that's 24 digits that are turned on, right? So 2 to the 24 possible networks. 32 minus 24 is 8, so there are 2 to the power of 8 minus 2 possible hosts. Okay. This is a tricky one. Consider 255.128.0.0/9. We know what 9 means, right? That's the number of bits that are turned on. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's what number here means. Pay attention here. This is a class A subnet mask because the first one is the maximum value, right? 255, but the second one is less than 255. But this is a class A. So how many bits there are turned on? 9, right? 2 to the power of 9 possible networks. How many bits there are turned off? 23. So 2 to the power of 23 minus 2 possible hosts. Okay, the last example. Consider 255.254.0.0/15. You know what 15 means, right? Just count the digits that are turned on, right? This 8 here, 9, 10, 11, 12, 13, 14, 15. So that's 15 here. This is class A because the first one is 255, but the second one is less than 255, although it's very close, just one off, but still this is class A. So how many digits there are turned on? Or 15. So 2 to the power of 15 possible networks. How many digits are turned off? There are 17. If you there's 8 here, 8 here, and 1 here. So there are 2 to the power of 17 minus 2 possible hosts. Okay, so I hope all that makes sense. So when do you use, or why do you have to use the subnet mask? Because within the same map of devices that are physically connected together, maybe you will want to divide them into different subnets, and there's a requirement that, like, I don't know, subnet A requires certain number of hosts and subnet B requires another wanted number of hosts, something like that. So it's a way of subdividing a physical network into different subnets. Okay, thank you very much, and see you next time. Cheers.